Good morning, good afternoon, good evening, ladies and gentlemen. And in today's video, we're going to be looking at trigonometric identities. Now, trigonometric identities are equations that are true for all values of the variable for which the expression on both sides is clearly defined. So, for instance, if we actually know about a very nice expression from very long ago, so for instance, we know that tan of theta is equal to sine of theta divided by cosine of theta. Now, this I would say is definitely a trigonometric identity because both sides of the equation are true, because I know that that tan of theta is the same thing as saying sine theta divided by cosine theta, which we showed earlier on and then in another lesson when we were talking about the special triangles, even when we were talking about the terminal arm. So, what do I do with this information? Well, we can use it to find other things as well. For instance, we know about cotangent. We know cotangent of theta is the same thing as saying 1 over tan theta. But now, thanks to this, I know that this is the same thing as saying 1 divided by sine of theta divided by cosine of theta. We also know that whenever you divide by a fraction, it's the same thing as saying that we are going to multiply by the reciprocal of that fraction. And 1 times anything is usually itself, so my final would be cosine of theta over sine of theta. So, cotangent of theta is equal to cosine of theta divided by sine of theta. These two right here, this one and this one, so one, let's go over this one here. These two are called the quotient identities. Now, we also have what we call Pythagorean identities. I'm not going to prove those ones, and you don't need to know how to prove them for, well, at least for grade 11. Later on, if you do decide to take Mathematics University and real analysis, you're going to have a very fun time proving them. But these are called the Pythagorean identities. And yes, I spelled Pythagorean right this time. Woohoo! Teacher's good today. Okay, so the Pythagorean identities. Well, the first one says that if I have sine squared of theta plus cos squared of theta is equal to 1. Now, we know this, and I'm not going to prove it for you, but we remember if we did our grid and we had a terminal arm here, if you remember, this was big X, this was the big Y, and we know in a unit circle that this should have been 1. So if I use Pythagorean theorem, it would get x squared plus y squared is equal to 1. We also learned that sine should also be opposite over hypotenuse. So if sine is opposite over hypotenuse, so this is my theta, my opposite would be y, and my hypotenuse obviously is 1, so y divided by 1 should be y. So that's y squared. And of course you have here for your cosine. Cosine should be adjacent over hypotenuse, so x divided by 1, so x, so cosine squared is x squared. That's just a quick, very, very small explanation of where it comes from. Again, I'm not going to be asking you how to solve that in any of the questions I'd give you, but just for anybody who's curious. Alright, second one. 1 plus tan squared theta is equal to secant squared theta. Okay, once again, you don't really have to know where these come from right now. Okay, and these are just always true. And 3, 1 plus cotangent theta squared is equal to cosecant squared theta. Okay, so these are the trigonometric identities. They are identities, which means that they are always true for every single value. So, what do I use these for? Well, I use these to help prove other things. So, let's go into an example and see what I mean. Okay, so let's see what we would do in these kind of questions. So it says to prove the following trigonometric identities. Now, for something to be proved, you have to be able to show without a shadow of a doubt that your left side is equal to your right side. So basically, it gets you the same thing when it's all said and done. So how you do these questions is you want to split it up into left side, right side. So my right side is sine x. That is basically as small as it can go, so I'm done with that side. It's equal to your left side. Now in the future, instead of using left side, right side, I'm going to be using LS and RS because it's short form, and you know mathematicians, we love our short forms. So how do I do this? Well, 1 minus cosine squared of x. What does this remind me of? Well, I know from the following page, the previous page, we said that sine squared x plus cos squared x was equal to 1. So if I were to solve for, let's say, getting sine squared x by itself, well, what would I do? I would take this cosine squared x and move it to the other side. So I would have sine squared x is equal to 1 minus cosine squared x. So this is just an aside here. So I noticed that sine squared x is equal to 1 minus cosine squared x. And I see here I have 1 minus cosine squared x on the top. So I can just substitute in sine squared x for this expression. So I'm going to have sine squared x up there. Sine x can't do anything with it. What can I do here? Well, I've got sine squared x, sine x on the bottom. Sine squared x is the same thing as saying sine x times sine x. We have a sine x on the bottom. One of these sine x's is going to cancel out, which is going to leave me with sine x. So on my left side, I've got sine x. On my right side, I've got sine x. So I can say conclusively, left side is equal to right side. QED. So basically I'm saying that, yes, this is true. 100% true. Why? Because my left side is equal to my right side. Okay, so at this point I want you to try to pause the video and try to do part B yourself. Okay, I assume you're back. Great. So what can I do here? Well, same thing. I'm going to notice again I have 1 minus sine squared x here. So as a little aside, here sine squared x was equal to 1 minus cos squared x. So what would give me 1 minus sine squared x? If I was solving for cos squared x, because I'd move this one to the other side. So I can change that expression into cos squared x. Okay? So again, remember this is your left side. As for my right side, well, what's secant x? Well, secant x is the same thing as saying 1 over cosine x. Can't do anything more on my right side, so I'm leaving that alone now. So on my left side here, I'm noticing that I have cos x divided by cos squared x, which is the same thing as saying cos x divided by cos x, cos x. Can cancel out one of my cos x's, giving me 1 over cosine x. Can't do anything more there. What do I notice? Well, I notice my left side is equal to my right side. Bingo! So I can say, therefore, left side is equal to right side. Therefore, it's true. Okay, let's try out 2 more examples. Okay, so let's try these examples. Now, these are a little bit more difficult because there's more steps involved, but I have confidence we can do these. Remember, with our identities, we can do anything we want, as long as you know who you are. Yes, after school speech, I'm sorry. So, pause the video, try it out yourselves. Okay, welcome back. So, let us break this down. So, we know this is my left side. We know this is my right side. Can I do anything with my right side? Nope. So I can just write it as sine x minus 3, sine x plus 3. So I can't do anything there. What can I do on the top? Well, on the right side, on the left side, I mean, if I look at the top, best thing you could do in these type of questions is to kind of look at sine squared x minus 6 sine x plus 9. So I'm going to do a little bit of an aside here, just to show you what I'm looking at. So I'm going to let sine x equal to just an x. So basically, sine squared x is x squared minus 6 sine x, which is 6x, plus 9. So this expression is the same thing as saying x squared minus 6x plus 9. What is this expression? Well, this expression is a perfect square. How do I know this? Well, a perfect square, I know that my first term here, so if I wanted to remind you guys here about perfect squares, so a is x, b would be whatever the square root of my last term is, so square root of 9. Is 3. So remember, perfect squares should always be in this form, a squared plus 2ab plus b squared. Is that true? Well, x squared, which is my a squared, is x squared. Beautiful. 3 squared is 9. So I have my a squared, I have my b squared. X times 3 is 3x times 2 is 6x. So this is all true, which means I can factor this. It's just a quick reminder about perfect squares and factoring of quadratics here. I can turn this into x minus 3 squared, because I know that this is equal to a plus b squared. Okay? Now, if you don't believe that, you can do x minus 3 times x minus 3 and see what you get. You'd get x squared minus 3x minus 3x plus 9, which would give you what you have there above. So that's a little bit of a aside here. Now again, you don't have to do these as little asides. I do them just to remind you of little facts from before. So knowing that, I can say the same thing for my top here. I can say, so assume now, what can I say here? I can say my a sine x, my b would still be 3, because square root of this one is 3. Square root of this one would be sine x. So with that in mind, I can now make my term, which means I can say that my top should be sine x minus 3 squared. Beautiful. And on the bottom, we're going to use another term here. If you guys remember, it's a little bit of a side up here. A squared minus b squared is equal to a plus b times a minus b. Okay? Remember, difference of squares. That only works when you have two perfect squares with a minus in the middle. I have sine squared x. That's a perfect squared. 9. That's a perfect squared. That's 3 times 3, and a minus in the middle. So it follows this form. So I can turn my bottom into sine x minus 3 times sine x plus 3. So remember, sine x minus 3 all squared on the top. That means there's 2 of them. I already have this same expression right here, only one of them though. This other one's a plus, which means I can cancel out one of these ones on the top by canceling out this one, leaving me with sine x minus 3 over sine x plus 3. That's all I can do here. Can I compare these now? Let's see. I've got sine x minus 3, sine x minus 3, check. Sine x plus 3, sine x plus 3, check. Man, I'm good. I can say now with complete confidence, left side is equal to right side. So this is true. And we are proved. Alright, let's move on to the second one here. Please pause it, try it yourself, as usual. Okay, you're back with me. Great. Obviously, if you're not pausing them, then this would be very funny. Now, it does seem I have enough room here, so I'm going to actually devote another slide, this one over here. So let's do this when we come back. Okay, let's take a look at this. So, you have your left side, your right side. So I can't really do much with my left side, so I'm going to leave it by itself over here. Now, this question is tricky in its own sense. I'm going to show you why. So let's use what I know here so far. I know that secant of x is 1 over cosine of x. And I know that tangent of x is the same thing as saying sine x over cos x. Now, in this case here, you would end up having 1 plus sine x divided by cosine of x. That's not going to get me anywhere. So the only way you can go forward in this one, and this is why I'm saying tricky, it's because you have to be able to see ahead here. And I'm noticing if I want to have, and I want to get rid of that 1 on the top, for instance. Well, I can just multiply everything by whatever my bottom is. This way, I'm getting rid of this one over here. I could also use that 1 is the same thing as saying sine squared x plus cos squared x, but that won't get me anywhere. Well, it will, but it'll take you much longer to do. So let's see what we have when we do that. So that's going to give me cosine of x plus sine x cos x over cosine squared x. Okay? Now, why did I want to do that? That's because now I can be able to use some of my identities. For instance, on the top, I can factor out cosine, because I found in both of these I have cosine, cosine. So let's factor out cosine, which will leave me with, well, cosine divided by cosine is 1. Sine x, cos x divided by cosine would also be sine x. Okay, and on the bottom, cos squared x is the same thing as saying 1 minus sine squared x. It's from one of my identities. Now, I also know 1 is a perfect square. Sine squared x is a perfect square, and there's a minus in the middle, so this is a difference of squares. So I can turn this into cos x plus sine x. See why I needed a new page for this, which is going to give me 1 minus sine x, 1 plus sine x. Okay. So I have a 1 plus sine x on the top, 1 plus sine x on the bottom. Cancel these two out, which would give me cos x over 1 minus sine x. So what we got here, I've got cos divided by 1 minus sine x, cos divided by 1 minus sine x. My left side is equal to my right side. So it's proved. Alright. So I hope this has helped you in how to use trigonometric identities and solve problems. Have a good day.